Hello there, it's Jay here from Jay's Vintage Junk, and today I thought we'd take a look at this Fieldworks military computer that I got. If you've seen in previous video, I had a little bit of a drunken buying experience on eBay, late nights and alcohol on eBay, and I picked this thing up. I didn't pay a huge amount of money for it or anything, and basically it's a Fieldworks militarized computer, and I believe these were used in like some of the early Hummer vehicles, military vehicles, things like that. It doesn't work. You can put power up it, the power light comes on, but that's all it does. So what I thought we'd do in this video was we'd crack it open, we'll have a look inside, see how it's put together. I've got my multimeter out, and we'll just do some basic checks, just some voltage checks on the power supply, things like that. See if we can figure out if it's anything really simple that's wrong with it before we have to delve into other diagnostics. I would really like to get this thing working, for the simple fact that I think this would make the most awesome portable retro gaming rig imaginable, because it's, I mean, the processor's ideal for retro gaming. It's got I think a Pt1 or a P233 MMX CPU. It's got Sims RAM in it, takes standard hard drives, it's got a reasonable screen on it. It's got PCI and ISA slots in there. We can put a proper sound card in it, things like that. So anyway, what I'll do, I'll get the camera set up so you can see what I'm doing, and we'll crack into this thing, and we will see what we find on the inside. So back in a sec. Okay, hopefully you can see that alright. Right, now, the first thing I'm going to do is take the base off. It is rather heavy. Oof. Right, there we go. We seem to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 Torx bits across the bottom. So hopefully I've got need something smaller than that. Let's try that. Ah, there we go. We've got one that fits. A screwdriver here as well. Right. Let's see if we can get the base off and have a look inside it. It's all metal, this as well. I'm guessing it's cast aluminium. It's quite heavy. It's not a lot. It's certainly not a laptop. It's well, it's, for one thing, it hasn't got a battery per se. It has like a UPS system. I've actually removed it. It was on the top, but there's very obvious signs that the batteries inside it have started to leak. I think that's what's damaged one of the catches on the back of this. It might actually be what's affecting the motherboard, we never know. But there's definitely some signs of battery leakage from that UPS pack. So I did unscrew that, actually just after I've made that first video on this thing. There. This is a lot of screws. I'm wondering, no, I don't know. I don't know if we have to take all the screws out to get it apart or not. Oh, let's just take all the screws out and we'll see what happens. I thought those, well, they're a different size. I think that's the same. Yeah, those are a different size. So I wonder if they actually hold something down inside. I'll take them out anyway. There's another one. I wish I could find out how much this thing costs new. I bet it would be a ridiculous amount of money. Anything that's made for military use costs, you know, many times more than what the civilian version would cost. Because I'm going to have to revert back to the video now so I can remember which screws go in which holes. Actually, I think it's fairly obvious, but... Right, that's the last one. And let's see whether... There we go, we're in. Okay. So what can we see in here? Well, there's our back plane. We've got our CD-ROM drive under there. A motherboard here. And it looks like we may actually be able to separate the motherboard from the rest of it and actually have a look at that separately. Just grab my anti-static. So we are going to be handling the board and what have you. Put my anti-static wrist strap on. Now this is ridiculously tight in here. This just lift up and pull out. It does look like you should just be able to lift it up and... Yeah, there we are. That's free. Disconnect the parallel cable. Not sure what that one is there, we'll get that off. So there's ribbon cables going literally everywhere here. And we have to be incredibly careful with this, trying to extract the main board and not damage any of these little connectors. It lifts up there alright, but there's got a power connector there. Ah, that makes life a bit easier. Right, because one of the things I want to do is get down to the actual power supply, because that could possibly be what the issue with this computer is. Right, we've got a connector here I think we can disconnect, hopefully. Yeah, everything's taped down. There we go, that's coming off. Is that IDE? That might be IDE there. Right. And then we've got, what's that PC? That's the fan here. Let me see if I can disconnect that. That's the fan off. I've got these two serial ports here. I think we can disconnect that. That's one, two. We've got, is that the PC speaker? I think this is the PC speaker. Disconnect that. Slowly get in there. Right, now got another cable here. That's that out. Just slowly turn the board over. Right, this is there's these really fiddly little plastic cables at the front here. I need to get that out. I think that's for the PCMA slot. Right, now that's our video connector there. There's another connector here I need to disconnect. That's that off. Then I think the final thing is this this video connector. Which does look a strange thing. How does this disconnect? Ah, push that up, push that up, push that up, and it pops off, I think. Oh, it's held on with some, like a foam pad. This is going to be tricky to do. Ah, there we go. Foam pads come off, and we finally have the motherboard out. Right. So that is the motherboard. Get you zoomed down onto that so you can have a proper look at it. So the floppy drive is actually fixed on as part of the main board. That's our VGA output there. Obviously we've got an external VGA output on it as well. So it should be possible to fire this board up out of the actual rest of the laptop for some testing. Let's see if there's anything that's actually marked on the board what they are. I'm guessing that is IDE there. Yeah, I'm pretty sure that because it's a 44 pin IDE that. So that's our VGA, that strange connector there. We've got standard Sims RAM. We have another connector down there which I'm not 100. Oh, I think it's the PCI. I'm not sure actually. I'm not sure what that one is there. That is what the PCIMA socket was connected to. And I've got one bent pin there. Hopefully I can just bend that back. That large pin array at the back there is what lines up with the rest of the ISA and PCI connectors. So that's basically the bus all the way along there, which then lines up with them connectors across there. It's incredibly well built. We have a real-time clock battery down here. Let's see if we can get it out. Oh, that's crusty. That is very, very crusty by the look of it. This is going to be maybe a bit tricky to get out, I think. But I think we've found one issue already. Let's see if I can get in with my knife and get the sticky pad underneath it. Come on, snap. Dear me, these are ridiculous cable ties. There we go, that's one out. I'll try and get the other one. There we go, that's that one out. Ugh. There we go. So it was cable tied and velcroed in. Well, actually, it's not. I thought it had leaked terribly, but actually, no, it's not leaked. It was just incredibly strong Velcro it had been stuck down with. Let's see what it should be 3.6 volts. It's a 3.6 volt lithium. Let's actually see what voltage we've got coming out of that thing, because I'm pretty sure that's going to be dead. Get the meter on. We'll try to test this battery and we'll see if it's got any life left in it. I very much doubt this is going to have any power remaining in it. I don't believe that. 3.6 volts. So that backup battery is still absolutely perfect. Wow. So yeah, it's still fully, it's still got a full charge in it. That's amazing. And was there a date code on it? Yeah, 11th98. I don't know if you can make that out. There's a date code up there, 1198. So that's from that end of 1998, that battery, and it's still absolutely perfect. Wow, that's impressive. That is quite impressive for a lithium cell. Then again, like I said, military equipment. So, at least we know for now that we've the backup battery is still alright. Let's get the main board. In fact, let's have a quick close look at this main board again. So I want to be really careful of them contacts at the back there, because they would be so easy to damage and bend. It's going to be a right mare to bend them back because of that really fine pin pitch. Let's see, while we're in here, if we can discover what our CPU is. No, it's one of these. It's obviously a desktop CPU by the look of it. Come on. There we go. Dear me. I don't know what thermal paste they've used on that. Let me see if I can find something we can slightly lever that up with. What have I done with my knife? There it is. We'll very gently have a quick lever and just see if we can just... There we go. And what have we got under there? It is indeed a Pentium 233 MMX. It's a rather horrific thermal pad that I'll have to do something about that. But yeah, that's a Pentium 233 MMX there. I mean, the good thing is, if there's something wrong with the CPU, that should be fairly. I think I might have one of them kicking about. In fact, I wonder what other CPUs this board could possibly run. I wonder if it could run any of the AMDs. Put this back on. Obviously, I'll have to put some fresh thermal compound and sort that out properly. But I can't see any corrosion damage on the board at all. The board doesn't look in particularly bad. Well, it doesn't look in bad condition. You know, like I said, I can't see any nasty corrosion damage on there, and that was one of my concerns when I saw the condition of that battery. Was had any of it actually leaked inside here and caused any damage to the main board? But no, it doesn't look. You know, it doesn't look like it. It looks like it's actually survived quite nicely. I can't see anything on there that's actually been any signs of battery leakage on it. Now, I'll put that to one side for a second, and we'll turn our attention to the to the power supply, which is what I wanted to investigate. I believe the power supply is here. I don't want to disturb too much of this wiring because I think I'd have an absolute nightmare trying to get it all to fit back where it needs to go. I mean, that's really what we want to check. Basically, check the voltages coming off there and make sure they just make sense. Let's see what we should have. We should have 5 volts at 8 amps. We should have 12 volts at 1.2 amps. We should have a minus 12 volts at half an amp. And we should have a minus 5 volts at 0.25 amps, or 250 milliamps. So I think the first thing we want to do basically is see if we've got them voltages coming out of the power supply there. I think that's probably the most sensible test we can do. So obviously if the power supply's got a voltage rail missing, especially if it's something that's the motherboard actually needs to fire up, we're not going to have it powering up. This might be a little bit tricky to do. I think I'm going to have to put the case kind of on its side like this. I'm not sure what you're actually going to be able to see. I need to open the case, there it is, because there's the power switch in there. If I move this round, providing I can still actually get to the power switch to switch it on, which I can, I'll plug that in there. Right. We'll get the tester in, switch that on. Now, can you all see the tester? Hopefully you can. We'll connect the black lead to one of the grounds, which is at this end here. We'll switch on. And hopefully we should have some voltages on this power supply. What we've got, just a minute, this is going to be tricky to hold. If I put my hand up there, now let's start here. So we've got minus 12 volts there. We've got plus, just what, it's 11.96, but so we can call that 12 volts there, that's fine. We've got a minus 5 volts there. We've got our plus 5 volts. I'm just not sure what this end one should be. That's another plus 5 volts. So, yeah, basically the power supply seems to be working fine. We're getting all the voltages we should be getting out. So, move that out of the way so we can put this back. So we can put this back down. Let's have a quick look under here. So yeah, we've got the in that back corner there. I don't know if you can see that. That's the PCMA slot there. I think that goes. Oh right, so I was mistaken before. That I said was the PCMA slot, that bit of thin ribbon cable. That's not, it's the mouse, it's the track point. The PCMA slot there seems to go onto the actual back plane here. So I can't see anything wrong from this side. To be honest, like I said, that I think is that's the video output. Because where does that go? I'm not sure where that side of it goes. That obviously goes to the screen, and I believe that the VGA connector is actually on the on this board here. I think that's the VGA connector there. Yes, yes it is. So what we should be able to do, providing we can find a pin header that will fit that, is I can rig up like a standard, I could probably rig up an ATX power supply. I think that's got all the volt. No, because some of the ATX power supplies don't have the -12 on them. I'll dig out an old power supply that has all the correct voltages that we need on it, and we can actually then have a play at actually troubleshooting this board, and then we don't need the rest of the computer set up. We can just literally play with this main board and the screen, and once we can see if we can actually get this working, then we can actually see if we can get it working in the rest of the computer. So I'll see what I can do about finding a power supply that we can use for just powering this board up on its own. So back as soon as I've found that. Okay, it's actually been a few days since I was last played with this, but in that time I've made up a little adapter here. I've got an ATX power supply, not that you can quite see it on shot here, but I've got an old ATX power supply. I was going to use an AT supply, but all the ones that I trust are actually in computers that I don't really want to take apart. And I did find one that I tested it, and I weren't happy with some of the voltages I was getting out of it. It really needs looking at. So I dug out an ATX supply. Now, unfortunately, you can't use any ATX supply to do this, because more modern ATX supplies don't actually have a -5 volts rail on them. I think they have the -12, but they don't have the -5 that this board and like the earlier boards needed. The earlier ATX supplies that were considered like legacy supplies, you know, you remember the boards in the very, very late 90s that had an AT connector and an ATX connector on them, the motherboards. You need a ATX power supply from that kind of era, or just later than that. I mean, I think this one I'm using is probably getting on for 20 years old, but it does have the -5 volts on it. So anyway, I just robbed a connector off a scrap motherboard, wired the voltages that we need off that. I didn't have the correct connector for the board that we're testing here, so I've put some little crimp connectors. Well, they're actually the inside of Molex connectors, which I squeezed down so they're a little bit smaller, and soldered all the wires on, put some heat shrink on them and labelled them up, so I've got grounds there, -12 volts, what else have we got, -5 volts, etc, etc, plus 12 volts, you know, everything that we need, and they are all in the right place. I basically, the connector in the actual portable, I measured all that out, and I made a little pin out of where all the wires go, and I've just pushed those onto that connector. Now what I have had to do is connect an old scrap hard drive up to the ATX supply, because this board basically won't, it doesn't draw enough current to be able to switch the ATX power supply, so we've had to add that as a load to the supply to allow it to actually work. And to switch the ATX supply on, if no one knows about it, it's very, very easy. Basically all you have to do is ground the green wire on the ATX supply to switch it on. So I've just put a little switch here just to make life a little bit easier. So we can switch this on. I've already tried it, and unfortunately, like I said, we're basically exactly the same as we were before. I'll switch on. Now, I did hear a kick from the floppy disk. I can't remember if I heard that last time. But we've got the CPU fans going, so we're obviously getting 5 volts to the board, but we're getting no video activity. We do get the numlock, if you look on the keyboard there, working for a bit, and then after you've pressed it a few times it just locks on, which I think probably means that the keyboard buffer's working, but it's not been able to actually do anything. What I wanted to do next was actually basically see if the CPU's actually doing anything. We'll feel around the board, I can feel that Cirrus Logic chip just getting nice and warm. The ALI chip I think might be getting barely warm. I can't feel any. I'm basically doing a little bit of a heat test, and I can't feel anything getting ridiculously hot or anything like that. I've already looked over the board to see if I could see any, you know, like a shorted tantalum or something like that, and I can't find anything like that. I've actually checked using the multi-tester between ground and all the voltage rails, and there's nothing shorted to ground or anything. So, like I say, it's nothing simple like just a bad tantalum or anything like that. Right, now it's run for a few minutes. What I'm going to do is I'm going to whip the heatsink off the CPU. I just want to feel how warm the actual CPU is getting in this thing. If I can, there we go. Then we're going to have to put some new thermal pad on that. Let's have a feel. Now, it's not burning hot or anything, but it is. I'd expect it actually to be a little bit warmer than it is. I mean, basically the easiest things to test on this board now is things that are plugged into it before we get too in depth into it. And we've got two 72-pin SIMs there. They're going to be easy to test. We can test them in another system. And I'm wondering whether at this point, see, I've actually got a system right behind me here. Similar era to this. I think that uses an Intel. It either uses a 200 mmx or a 233 mmx in it. I must admit, I've not actually. I don't think I must have. I actually don't remember whether I've even turned that computer on or whether I just opened it up. It's one that I picked up off eBay a few years ago for a £5. As a mystery computer, and it weren't far from me, and it was collect home. And like I said, I got it for a £5, and when I opened it up, it were a Pentium MMX machine. But I've never actually done anything with it. I suppose I could see if that runs, and if it does, it'd be ideal for testing this the 72-pin memory and that CPU. In fact, how do we get that CPU out of here? Oh, I hate these sockets. I remember these. You meant to put a screwdriver. You remember on a lot of socket 7 sockets you have a little lever, and you use the lever and you lift it up like that and you move it across and it releases the IC. Now, I've seen these type before. I remember these, and they're horrible. What you have to do is put either a blade or a screwdriver or something in there and actually lever one way, and it actually releases the IC. I remember these. It needs to go that way, doesn't it? There we go. Got it. Let's take the CPU out. And that's stuck solid in there as well. Now it's released. That does not want to come out of that socket. There we go. Just very gently lever it up. In fact, I might go and get my dental picks to see if I can get under there to lift that IC out of there. So, back in a sec. Okay, I've got my dental probes. So, in fact, I better put my anti-static strap on. I had actually forgotten it before, but I'm anti-static now. Let's see if we can persuade this CPU to come off the board. So that's released that way, so it should be. It's definitely free now. I wonder what's holding it. There's definitely something. There's definitely something holding that CPU in there. Yeah, it's completely released. I wonder if I get two probes, one at each side of it, and we try and lever like that. I wonder if that's going to work. Obviously I don't want to break the socket. I mean, it wouldn't be impossible to replace, but it would be an absolute pain in the whatnot to do it. I don't think I've ever had a CPU this stuck in a socket. There we go. It's coming now. It's like, literally like, welded itself to the socket. It's coming up that side there. Have they glued it down? I've got a horrible feeling they've actually glued it to the they've glued it to the socket or something. It's coming up now. Right. Yeah. I don't believe it. They'd actually glued. They'd actually glued the CPU down. Well, I've never seen that before. But anyway, on the you can have a look there. This is your standard MMX Pentium 1 MMX CPU, and the board itself looks absolutely fine. It's just, well, it's the first time I've ever seen a CPU actually glued in place. Right, what I'm going to do, I'll put that up there out of harm's way for a second. I'll pull the RAM out of this as well. And this has got these really nice SIM sockets with the metal springs, not the horrible little plastic ones. So these are actually really quite reliable. It is a decently built board by the look of it. There we go. That's that one out. So we've got two 72-pin SIMs there. I'm not sure what size they are. I'm guessing they'll probably be probably 8 meg, to be honest. I'll work it out from here. Well, I'm not sure. I'm not looking up the chip just now. They're probably 8 meg, but we'll find out. We'll find out very shortly. Anyway, so what I'm going to do, we'll disconnect that from there, and I'll leave my harness connected to the board, and I'll go and find an anti-static bag, and we'll put this board in an anti-static bag where it's safe. And I'll pull out that other Pentium MMX machine, and we can have a go at testing the CPU and the RAM from this computer in that computer. Just to confirm, I mean, it would be absolutely fantastic if it's something simple like a bad CPU or something like that. I've a horrible feeling it's not. I have a horrible feeling there's a fault on this board somewhere. If it's that ALI chip, I think we're pretty well screwed. If it's anything else, we do still stand a chance of actually possibly getting it working. Anyway, I'm going to pause the video. I'll get this squirreled away. I'll dig that other Pentium MMX machine out, and we'll have a look at testing that CPU and that RAM. So back very shortly. Okay, and here we have a rather uninspiring late 90s beige box, but hopefully we can use this as a diagnostics tool. I'll get the lid off it. I'm hoping this is still complete. I think I showed this on a video when I first got it, and we just took the lid off it and said, "Oh, yeah, it's a Pentium." And I think that's as far as we went with it. I don't even think we tried powering it up. So obviously, like I said, the CR32 will be dead in it and things like that, but it should still work enough to do what we want it to do. Let's see what we've got in here. We've got an S3 Trio video card, we've got a modem, and we've got a generic ISA sound card, Sound Blaster clone by the look of it. So it's a very much run-of-the-mill late 90s Pentium system. I used to build many systems like this back in the day. And I think if we look under here, yeah, there we go. We've got a Intel Pentium MMX CPU. I'm not sure it's a 233 or a 200, but either way it should do for testing. In fact, I have a number of times back then actually overclocked the Intel 200s to 233 without any problems. Couldn't really do it with the Cyrixes, and you couldn't do it with the AMDs so much, but you could get away with it with the old Intels. Right, let's first of all let's see if this computer actually works before we start swapping things in and out of it. The other thing I need to see is what RAM it uses, and that's buried right underneath the power supply, which is a shame. Yes, it seems to have DIMMs in it. I'm hoping there's some SIM slots down there as well. Ah, yeah, it's got SIM and DIMM slots. Right, first things first, let's get this thing and see if it actually works. Put some VGA in it. We won't bother connecting a keyboard, we don't really need to. Not at this point anyway. We need some power up it, don't we? Got a IEC lead here. We'll plug that in and wait for the pop. We haven't had a pop, that's good. We'll switch the monitor on and we'll switch the power button on. Right, it's actually fired up. It's counting up its RAM. And it is a 233, excellent. It's got 32 megs of RAM in it as well. Right, okay, brilliant. I'll switch it off at that. Right, so we do have a working platform here. I did actually see a hard drive in there, but that doesn't matter at all. First thing we want to do, first thing I'm really curious about is I'm going to whip the 233 CPU out of this, and I'm going to put the 233 CPU off our board on it. So out with our GNOME working 233. And we'll put the 233 out of the Fieldworks machine into this computer. And we'll put the heatsink back on. I mean, for a few seconds test it probably will be alright, but I don't want to risk it. Not for the couple of seconds it takes just to snap a CPU fan on like that. I'll get you up on the screen. It's probably going to work because we can't have anything as simple as just a failed CPU, can we? Let's switch on. And yeah, there's nothing wrong with that CPU. There we go, Pentium Max CPU at 233. Now that's weird. Why is it counting up a different amount of memory? Yeah, that is odd. It counted up like 32 meg last time, it's counted up 98 meg this time. That's peculiar. Oops, excuse me. Let me just swap back to the original CPU. And oh great, this CPU is now, let me see if I can get it out. It's stuck itself to the socket like it had in the yeah, it's done what the it had done in that Fieldworks. It's stuck itself to the what the bloody hell have they put on this CPU? Right, hang on. Let me put it back down. Put that one to one side. And I don't suppose it really matters which CPU I put back in. Being they're both exactly the same Intel. Let's try it again. Yeah, definitely, I can't see anything wrong with that. Right, so I suppose all we've really got left to do is test the RAM. See if this RAM's alright. Now I wouldn't expect dead RAM to give us the symptoms we're getting a completely dead computer like that. I'd expect some error beeps, or even to boot and just come up with a RAM error, but you never do. You can never tell. Right, where's my screwdriver gone? Because this is going to be a mare now, because the RAM sockets are buried in this system. In fact, I'm just going to pause the video and I'll dig around in here and I'll see if I can get down to the SIM sockets in here and we can quickly test this RAM. It may even be quicker for me to pull my 486 out and test it on that, to be honest, but give me a sec. Okay, we've got the 64 meg and 416 meg SIMs out of this. Why it was saying it had like 100 meg of RAM, I don't know. It had 64 meg of RAM anyway. There it is. And I've put the two SIMs from the Fieldworks in here, and I will say I am not going to be keeping this computer in the configuration it's in. It is bloody horrible. I've basically had to pull all the connectors out. I've had to pull the power supply out just to get to the SIM sockets, and they're right underneath this piece of metal here. It's just took me like 25 minutes to get the old SIMs out and the new SIMs in. I'll find some other nice board to go in this case, and possibly find another case for this MMX board as well. But that board just does not work in this case. Right, anyway, let's switch on and see how much memory we've got. I'm pretty sure it's actually going to work, to be honest. But I don't know how much memory we're going to count up to. 32 megs, so we've got two 16 meg SIMs and they seem to work absolutely fine. Right, so we have tested the easiest things to test on this. I think I'm probably going to call this a part one of a multiple parter. It will be, won't it? Because essentially, like I said, we've tested the simple stuff. We've got the board out. It's going to be down to testing some voltages on the board. I'm still hoping it's going to be something simple and we just lost the voltage somewhere or something like that. So if it's like ALI chip or anything like that, I think we're pretty buggered, to be honest. So I'm going to leave it there for now. I hope you enjoyed this little video, because if I can get it working, it's going to be such a cool little retro gaming machine that I just love to play Quake and Duke 3D and things like that on it. It should be pretty awesome. So anyway, I'm going to leave it there for now. I hope you enjoyed this little video. So thanks for watching and goodbye.